Hello everyone, Mr. Fawcett here, and we are back with another geometry lesson. Today we're going to talk about some more angle relationships in circles. We've talked about central angles, we've talked about inscribed angles, and now we're going to talk about angles that are formed by a combination of chords and tangents and secants. And you'll see that there's theorems that go along with these angles as well. We are going to skip the do now. Actually, no, we're not. Let's get our brains in gear before we tackle a bunch of theorems. Let's quickly answer number one. It says find the measurement of angle NMP, that is the central angle, and find the measurement of angle NLP, that is our inscribed angle. Pause the video, go ahead and do that. Come back and see if we got the correct answers. Okay, so NMP, that is our central angle. Let's outline that in orange. And we know that central angles have the same measurement of their intercepted arc. So their intercepted arc is 110. That means this angle has got to be not 55. I'm getting ahead of myself. 110 degrees. Central angles have the same measurement as their intercepted arc. So measurement of angle NMP is equal to the measurement of arc NP. So NMP is equal to 110 degrees. Inscribed angles, it's a little different. All right, inscribed angles, let's do this in red. There's two ways we could think about this, right? We know that if an inscribed angle and a central angle intercept the same arc, which they do here, then the inscribed angle is half the measurement of the central angle, or you can think of it as being half the measurement of the intercepted arc. Both will get you the same answer. So measurement of NLP is equal to 1/2. I'm going to use the arc here. Measurement of arc NP. So it's going to get us 55 degrees. All right, now that our brains are in gear, let's tackle our first theorem. We already talked about this relationship up top. The relationship between the measurement of angle B and the measurement of arc AC. B is going to be 1/2 the measurement of arc AC. So let's jump down to the theorem, which talks about angles formed by a tangent and a secant. So if a tangent and a secant, or a chord, if the secant does not extend right past the circle, if it's just a segment, if they intersect on a circle at the point of tangency, then the measure of the angle formed is half the measure of the intercepted arc. You're going to notice that a lot of these theorems today are similar to ones we've already talked about. So this angle right here in red, ABC, that is going to be equal to 1/2 the measurement of this intercepted arc in orange. So 1/2 the measure of arc AB. So it has the same relationship as inscribed angles, right? Except inscribed angles, we're dealing with two chords or two secants rather than a secant and a tangent. Let's apply this theorem to one problem. Let's do number one. We have to find two angles, the measurement of angle BCD and the measurement of arc ABC. Go ahead and attempt those. Come back and see how you did. Okay, let's start with the measurement of angle BCD. This is one of those angles formed by a tangent and a secant. And we know that's going to be half the measure of the intercepted arc, which is 142 degrees. So the measurement of angle BCD is equal to 1/2 the measurement of arc BC, which is 142. Measurement of arc BCD ends up being 71 degrees. We know it has to be less than 90, right? Because it's only part of that 90-degree angle. So that kind of lets us know that whether we're on the right track or not. Speaking of that 90-degree angle, that's going to help us figure out the measurement of arc ABC. Right, we want to figure out the measurement of this arc right here. So we can look at the angle that intercepts that arc, which is ACD. That angle is 90 degrees, which means the arc will be twice as much. Right? The measurement of angle ACD is equal to 1/2 the measurement of arc ABC. Well, if I know the angle is 90, I just need to multiply both sides by 2. And I get the measurement of arc ABC is equal to 180. Special name for arc ABC if it's equal to 180 degrees. Pause the video, 5 seconds to think. It's going to be a semicircle. Right? Semicircles are arcs that have measurements of 180 degrees. Okay, we'll leave the other one for in class. Let's move on to another theorem. We're just powering through these theorems today. Next one says if two secants or chords intersect in the interior of a circle, then the measure of each angle formed is half the sum of the measures of its intercepted arcs. So again, they're throwing a 1/2 in there, but it's not quite the same as before. Let's take angle 1 for example. So what you may think is that if this arc was 90, that angle 1 would be 45. That is not what this is saying, though. Angle 1 is not an inscribed angle. The vertex is not on the circle, so it does not follow the inscribed angle theorem, where the angle is 1/2 of the arc. It's also not a central angle, right? So it's not going to be equal to 90 degrees. It's not going to be the same as the intercepted arc. When the vertex is not on the circle and it's not at the center, you actually have to look at both intercepted arcs. You have to look at the intercepted arc for number 1, and you have to look at the intercepted arc, did not mean to erase, for the angle that's vertical to 1. So this one in green. So to figure out angle 1, you have to know the measurement of arc AB and CD. I'll do CD first because I'm already in green. Plus the measurement of arc AB. Now it's not just the sum of those, it is half the sum. So I add those together and I multiply by 1/2. That's how we find an angle that is where the vertex is inside the circle but not the center of the circle. Go ahead, apply that theorem to number 1 down here. You got to find the measurement of angle SQR and the measurement of angle PQS. All right, let's do SQR first. Hopefully you've paused the video, you've attempted it. So I need to look at the 32-degree arc. I need to look at the 100-degree arc. Again, I'm finding SQR. We'll call that theta. So theta is equal to 1/2 the sum of 100 plus 32, which means theta is equal to 1/2 times 132. Theta is equal to 66 degrees. If theta is equal to 66 degrees, does that help us figure out the measurement of angle PQS? Measurement of angle PQS. Let's call that alpha. You know, I like to use some Greek letters for angles. Well, alpha and 66, what's the relationship between those two? Well, they're linear pairs. Right, so alpha I just wanted to shorten it so I didn't have to keep writing out the measurement of angle PQS. Alpha plus 66 must be equal to 180 because they're a linear pair. Alpha must be equal to 114. And of course, alpha is the measurement of angle PQS. All right, keep the theorem in your pocket. You'll have to use it later on. Looks like we have one more to go today. I think just one more, unless I put another one in. We're going to skip the proof for time's sake. Trying to make this video a little bit shorter than the other ones. Those are pushing 25-30 minutes. This last one looks complicated. It's not that complicated. This one just has three different cases. So it's a combination of tangents and secants. And this is when the angle is outside the circle. So up until now, we've either done central angles, which are at the center of the circle. We've done inscribed angles, which are on the circle. We've done angles that are on the circle, but where one side is a tangent instead of a chord or a secant. And we've done angles whose vertex is inside the circle, but not the center. This is the first example of us doing an angle where the vertex is outside the circle. And again, you'll notice there's some 1/2s here again. So if a tangent and a secant, two tangents or two secants intersect in the exterior of a circle, then the measure of the angle formed is half the difference of the measures of the intercepted arcs. If the vertex is inside the circle, well, then the measure of the angle is 1/2 the sum of the intercepted arcs, the opposite intercepted arcs. Here it's 1/2 the difference. So let's actually apply this to problem number 1. I think it'll make more sense if you see it in action. If I'm trying to find the measurement of angle S, notice that this angle intercepts the circle twice for each part of the angle, right? Each secant intersects the circle twice. So we get two intercepted arcs. We get this one in orange, this intercepted arc, and we get this one in red. And you have to factor in, those are on the same point because it's a tangent. You have to factor in both. X is equal to 1/2 the difference, and we're going to take the larger one minus the small, right? Otherwise we get a negative angle, which doesn't really make sense here. So 174 minus 98. X is equal to 1/2 times 76. X is equal to 38 degrees. All right, we are going to stop it there. I know we've thrown a lot of theorems at you in terms of, angles and how they're being measured, but it really just depends on where the angle is located, right? If it's inside the circle, it's going to be 1/2 the sum of the opposite intercepted arcs. If it's on the circle, well, it's going to be 1/2 just the intercepted arc. And if it's outside the circle, well, we have 1/2 the difference of the intercepted arc. So the more we practice, the better you'll get at just applying these, and you won't have to, think too hard about them. But we'll leave it here for today, and we'll finish the rest of these in class. As always, enjoy the rest of your day, and we will look forward to seeing you for our next lesson.